The ladder diagram has been and will be, to a certain extent, the traditional way of representing electrical sequences of operations. In the hardwired circuits, the electrical wiring is connected from one device to another according to a logic or sequence of operation. In a PLC, the devices are connected to the input interfaces, while the outputs are connected to the output interface. The actual wiring of the components is done electronically inside the PLC through the control program using the familiar ladder diagram symbols. For instance, this simple electrical ladder diagram, in which the pilot light is on if PB1 closes and LS1 closes, or if LS2 closes and LS1 is closed, can be implemented in a PLC by first connecting the control devices to the input interfaces, that is, the push button PB1 and the limit switches LS1 and LS2 and the output devices. In this case, the pilot light to the output interface. In the middle, which represents the CPU or the PLC itself, is the control program, which in this case is like this. Note the similarity of the two wiring configurations. The difference is that one is done hardwired and the one in the PLC sort of softwired. The operation in the PLC will be the same if PB1 is closed and LS1 is closed, because the PLC will read the status of the inputs, pass them to the program, and close their corresponding contacts, which will turn on the internal coil output representing the pilot light. The PLC will then send this information to the output module, which, when received, will turn on and the pilot light will be lit. In PLCs, the input modules are represented by this symbol, while the outputs are represented by this symbol. As we'll see later, the input devices, when connected to the input module, are set to have an address by which they are known to the processor when it is executing the control program. The same applies to the outputs. In this example, we address the elements in the control program by the same legend as the devices for simplicity. We'll see more on this later. Some of the benefits PLCs offer include the smaller space or footprint they occupy, the modular architecture of input and output modules, which allow it to virtually interface with all field devices, and perhaps the most important of all benefits, its reprogrammability, which simplifies changes and modifications in the field. PLCs make installation of control systems much easier to implement, while its maintenance is minimal. PLCs are truly workhorses on the plant floor, capable of withstanding relatively high humidity and temperatures encountered in the rugged industrial environment.